Hello, good day everyone. We will be presenting our report entitled Embryo Transfer Technology in Cattle. Overview. Embryo transfer technology in cattle is a reproductive technique that allows cattle breeders to produce offspring from superior females, which are donor cows, and superior sires, which is bulls, more efficiently than traditional breeding methods. It involves the collection, evaluation, and transfer of embryos from the donor cow to recipient cows. Additionally, embryo transfer techniques have improved over the years so that new methods of controlling ovarian function facilitate super stimulation of donors and synchronization of recipients, and non-surgical procedures facilitate on-farm embryo transfer.
Benefits of embryo transfer technology. Time embryo transfer, ovum pickup, and superovulation are playing an important role to reduce generation interval and increase genetic improvement in cattle. In different studies, it is shown that embryo transfer is a safe technique and it does not transmit infectious diseases. Therefore, it has been indicated that the use of embryo transfer is a salvage genetic material in case of the disease outbreak, and it is a valuable choice in demonstration of disease-free herds. The usage of ET technology is increasing in cattle by more offspring production and short lifespan. Normally, cows are monotocous. Their ovaries have the potential to ovulate routinely, one ova and two ova rarely, and only one single offspring can be obtained from cow per annum.
These are the steps and concepts involved in embryo transfer technology in cattle. First is selection of donors and recipient cows. Cows are selected based on their genetic quality, health, and reproductive history. These cows should have desirable traits such as high milk production, good conformation of specific genetic markers. Recipient cows are typically selected to their good reproductive health and ability to carry a pregnancy to term. They serve as surrogate mothers for the embryos. So, the donor cows dapat is na genetic value, physical condition, and dapat na siya desirable characteristic like high milk output or good conformation or certain genetic markers should be present in these cows. The second one is superovulation. Superovulation is to increase the number of viable embryos for collection. Donor cows are typically subjected to a superovulation protocol. This involves the administration of hormonal treatments such as follicle stimulating hormones or FSH to stimulate the development of multiple follicles, each of which can potentially produce an egg. So the donor cows daw are frequently put through a superovulation technique in para ma-enhance ang numbers of viable embryos available to harvest. Then in order to promote the growth of several follicles, each of which has the potential to produce an egg, and need siya og injection of hormonal therapies such as follicle stimulating hormone or FSH. So ang FSH daw is muna siya ang motabang to control the menstrual cycle and stimulates the growth of eggs in the ovaries. The third one is artificial insemination. After the superovulation protocol, donor cows are inseminated with semen from the desired bulls through artificial insemination. This step allows for controlled breeding to ensure the genetic quality for the resulting embryos.
So next is the embryo collection. So by collecting an embryo, it approximately 7 to 8 days after insemination. The donor cow's reproductive tract is flushed to collect the embryos. This is done by using catheter and flushing medium that is carefully filtered to recover the embryos. Fifth is embryo evaluation. The collected embryos are checked for its quality and stage of its development, and those high quality embryos are used for transfer, and the poor quality embryo are discarded. So next is the embryo transfer. The evaluated embryos are carefully transferred into the uterine horns of the recipient cow, and it is done through non-surgical process by passing a catheter through a cervix into the uterus. However, surgical process or techniques may be used in some case. So as you can see in this figure, it shows the diagram of the process of the embryo flushing and the recovery procedure.
Pregnancy monitoring. Recipient cows are monitored for pregnancy using techniques such as ultrasound. Successful pregnancy result in the birth of calves. Calving and rearing. Once the recipient cow successfully carries the pregnancy to term, she gave birth to the calves. She ca- these calves are considered the offspring of the donor cow and the chosen bull.
These are the steps of embryo transfer. Donor cow. 8 to 12 days post-estrus follicular wave manipulation. So, superovulation and step 2 5 days after initiating superovulation. Insemination. Natural or artificial. Step 3 6 to 8 days after insemination, non-surgical recovery of embryos. Flushing. 1. Isolation and classification of embryos. 2. Temporary holding of fresh embryos. Freeze embryos indefinitely in liquid nitrogen at 196 degrees Celsius. Recipient cow. Step 6. Detect natural estrus. Fixed time embryo transfer. Synchrony and natural or pharmacological. Step 7. Fresh embryo in holding to recipient cow embryo in liquid nitrogen. Direct or tow procedure before transfer to recipient cow. Embryo transfer 9 months later.
Conclusion. Embryo transfer technology offers several advantages in cattle breeding, including the ability to propagate the genetics of outstanding animals, accelerate genetic improvement, and conserve the genetics of rare or valuable individuals. It can also be used to distribute genetics more widely by producing multiple offspring from a single donor cow. However, embryo transfer technology requires specialized equipment, expertise, and careful management to be successful. In addition, it can be pretty much expensive and may not be suitable for all cattle breeding operations. That's all. Thank you, goodbye, and God bless.